welcome back everybody. Patrick here, moving on to another question. We have to find the slope of the tangent to the curve y equals x over x squared minus 3 at an x value of 2. And we know the slope of a tangent for any function at an x value of a is equal to that difference quotient, the limit as h approaches 0 of f of a plus h minus f of a all over h. We've been using this formula here throughout the unit. And if you remember back in the lecture videos, I mentioned that there are two ways to do this. You can find the slope of the tangent at a specific point right away by plugging in that a value. So in this case, that a value would be 2. Or you could find first a general expression. So you keep the a value there, find a general expression for the slope of the tangent, then plug in that specific x value. So two different ways to do it. The benefit of finding the general expression first is that if they give you multiple x values, or they're asking for the slope of the tangent at multiple x values, you don't have to do this calculation multiple times. You just have to do it once, get that general expression, and then just plug in those specific x values into your general expression to get the slope of the tangent right away. However, in this case, they're only asking for the slope of the tangent at one x value. And this function here, x over x squared minus 3, if you were to do the general expression first, it would take you super long, just because of this x squared minus 3 in the denominator. There's just going to be tons of algebra. So in this case, what I suggest doing is just plugging in that x value of 2 right away for a. So we're going to be finding the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. So all we have to do now is we have to find an expression for f of 2 plus h, and this is y equals x over x squared minus 3. So this is the same as like f of x equals x over x squared minus 3. So f of 2 plus h, we just plug in 2 plus h for the x value. So that would be 2 plus h in the numerator, and then 2 plus h squared minus 3 in the denominator. And then minus f of 2, if we plug in 2 for x, we'll have 2 in the numerator, then 2 squared minus 3 is 1, and the denominator 2 over 1 is just 2. And this is still going to be all over h. So now this is a lot nicer to simplify. If you were to plug in f of a plus h and f of a, you can try it out. You'll see to get that common denominator after, it's going to take you forever to simplify that numerator. In this case, it's a lot easier because we are working with numbers and things can cancel out. So what's going to happen is, let's keep this 2 plus h in the numerator. 2 plus h squared, if you FOIL that out, you'll end up getting 4 plus 4h plus h squared. And then we're still subtracting that 3, and then we're going to be subtracting 2. And let's put this 2 like over 1. And this is going to be all over h. Notice here in this denominator, 4 minus 3, those are like terms, and those just simplify to 1. Right, so we got 4h plus h squared plus 1. Let's actually put this h squared in front, so make it look a little nicer. So we got h squared plus 4h plus 1. And then you want to get that numerator into a single fraction. So what you do is you get a common denominator. So the common denominator would be this term, h squared plus 4h plus 1. So we multiply this 1 by h squared plus 4h plus 1, and then we multiply the top by h squared plus 4h plus 1. Right, so continuing this up here, if we combine these, we'll have 2 plus h minus, and then in brackets here, or let's keep the 2 outside, and then that expression there, h squared plus 4h plus 1. And this is going to be all over that common denominator we had, h squared plus 4h plus 1. And this is still going to be all over h. Okay, so if we distribute that negative 2 inside the bracket, what would we have? We would have, so if I distribute it inside the bracket, we'll have negative 2h squared. This 4h would turn into a minus 8h. You can write this on another line. I'm just writing it up here to save myself some room. And then this positive 1 would turn into minus 2. Right? So if we distribute that negative 2 inside the bracket, we would end up with that expression. Notice that the 2's cancel out, and then we'll be left with negative 2h squared. H minus 8h gives us negative 7h, all over h squared plus 4h plus 1. And then we're still dividing by this h, but it's like we're dividing by h over 1, so that's the same thing as multiplying it by 1 over h. Right? We still have to try to get rid of this h in the denominator. We can't plug in this limit as h goes to 0. I actually forgot to write this limit. So we should have limit as h goes to 0 here. Same thing up there. But notice from the numerator now, we can factor out an h. And then the h's would cancel out. So if we factor out an h from the numerator, we'll be left with negative 2h minus 7 all over h squared plus 4h plus 1. And then we'll be multiplying by 1 over h. Then notice the h's cancel out there. So if we plug in 0 for h, this goes to 0, this goes to 0, this goes to 0, and we're just left with negative 7 over 1, because this is like a 1 here, 1 over 1. So negative 7 over 1, that gives us negative 7, and that is your final answer. So a lot of work, but a lot less work if you were to keep that as f of a plus h and f of a. So the answer to the question is the slope of the tangent to this curve x over x squared minus 3, add an x value to is negative 7.